Hi there, everybody. So why the division algorithm? Well, that's a great question. The division algorithm has to do with the fact that, well, as we move forward in mathematics, we want to continue to formalize what we're doing. And so the division theorem, this particular statement, is one that we're going to end up using a fair amount. And so to be really specific, what this basically says is that when we let, actually, I'm going to see if I can change that to a different color so it stands out better. There we go. So if we let w and z both be integers, where z is not equal to 0, then we're saying that there exists some unique integers q and r, and I'll let you guess what q and r probably stand for, such that w equals q times z plus r. Okay? So this is kind of the basic definition of division, even going back to what you did in probably elementary school. You didn't probably see it in this form, but this is what it all came down to. Where if you're dividing w by z, you get some type of quotient and some type of remainder. Okay. We do say that r can be between 0 and z, and we are allowing z to be negative, but for the moment we'll take a look at positive ones. So a couple of quick specific examples is these two, where we've got 23 equals 3 times 7 plus 2. Pretty straightforward. I'm sure you're all looking at it going, what did I get myself in for? This seems really easy. Don't worry. These are just examples. 43 equals 5 times 8 plus 3, and you could probably come up with a million examples. I'm sure if I asked you all to write down 5 of them right now, you could do it. In fact, maybe pause the video and try and do that. See if you can come up with 5 examples of expressions written in this way. Okay, so why are we starting with some basic numbers, the stuff you've done in elementary school? Well, that's because, and we're gonna move over here. Actually, I'll just go like this. Oops, it's way over there. There we go. Sorry. There we go. Math is formal, and so the more formally that we can establish things, the more certain we are of the results. That's probably not particularly helpful, though. So the other thing is that this is really going to be helping us practice. We're going to get to be looking at something called the Euclidean algorithm. We're going to be talking about linear Diophantine equations and other statements that, some of which rely on the division theorem, and starting with some basic stuff that we all know well, it's a good place to begin. And then eventually we can generalize. Like when I look back at this over here, I'm like, okay, those numbers are pretty small, but eventually we're going to want to be able to say what happens when we make those numbers really, really large, or what can we say about a general statement about any set of numbers, not necessarily specific examples. Okay, so that's kind of a good explanation of why we're doing something that in many respects probably feels really obvious to you. But it's because we want to take it and use it as the foundation to do some stuff that may be a little less obvious. Okay, hopefully that helps, and talk to you later.